All right, folks, it's Bass Action, back in action here. On this page of notes, what we're going to do is we're going to look at how to graph our parabolas, specifically our parabolas that are in our new standard form. So let's start with the top one here that I want you to fully graph and is already in our standard form. And we're going to first just scan through this equation, looking for that squared term, because that's going to guide us on what we're going to do. And what we're going to see is that we have a y squared. That y squared immediately tells us that it's going to be a left-right parabola. And then we're going to look at the coefficient on the other side. Remember, it's always going to be on the opposite side. And when I see that that's negative, what that immediately tells me is that this parabola has to be opening to the left. It's important to have this in your mind because it'll help guide you when you're calculating other points. And if they don't follow that pattern, you know something's going wrong. All right, so looking at this equation, the vertex is going to be xy. We're going to look at the xy, and we're just going to read those straight from there. Remember, we will need to flip the signs. So our vertex will be the point 5, 3. So we can go ahead and we can plot that right away. Over 5, up 3, and that gets us our nice vertex. What I always like to do then is I like to immediately draw in my axis of symmetry. And since I already know my general shape, I can dash that in right away, and I can write the equation y equals 3. Okay. Then we're going to find our p-value. That means we're going to grab that coefficient, that negative 16. We're going to set that equal to 4p. It's always equal to 4p. So that gets our p-value of a negative 4. Okay, I'm going to go ahead put some boxes around these other answers that might help some of you. So that p-value of negative 4 is going to tell us a couple things. Based on that negative 4, what I know is that if I go 4 units in the left, to the left of the vertex, 1, 2, 3, 4, if I go 4 units to the left, that's going to give me my focus. And if I go 4 units to the right, 1, 2, 3, 4, okay, if I plot that point, I know that that's going to have to be the directrix and has to be a line. Knowing those two things, then I can answer those two questions. My focus is going to be the x coordinate from my vertex, and then I'm subtracting that 4, and the y value is going to stay the same. So the actual ordered pair is the point 1, 3, and if you look at our graph, that is in fact what we plotted. The directrix is going to be the x coordinate from the vertex, and this time I'm going to add, because I'm going in the opposite direction, that p-value, which will give me a directrix of x equals 9. Okay, and again, that matches my graph. Now, we talked in class about the lattice rectum. We typically will just refer to this as the LR, just to shorten that, just like we do axis of symmetry as AOS. The axis of symmetry is going to be perpendicular, or the lattice rectum will be perpendicular to the axis of symmetry. And the length of that segment will be equal to 4p. So our coefficient, that 4p, is 16. So through the focus, we're going to go 8 units up. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go 8 units down. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then that segment right there, that is called the lattice rectum, that LR. Now, the reason that that's useful is the end points of the LR are going to be actually on our parabola. So we can actually sketch in our parabola, because the LR is so long, we can actually sketch this parabola in right now. We've got enough information to make a pretty decent graph there. Now, if we wanted to go through and calculate the axis of the x and the y-intercepts, we could certainly do that as well. If we want to find our x-intercept, of course, we're going to let y equal 0. So we're just going to do some quick algebra. Our negative 16, x minus 5. Then on the right-hand side, our y value was 0. So we're going to have a negative 3 squared. It's kind of hard to read that negative 3 there. So negative 16 x minus 5 equals my 9. Then I'm going to go ahead and I'll have my x minus my 5. I'm going to divide both sides by that negative 16. So I'll have 9 over negative 16. Then I'm going to add that 5 to the other side. So x is going to be a negative 9 over 16 plus my 5 over 1. Of course, I would need to get my common denominators, which will give me an x-intercept of 71 over 16, comma 0. And if you approximate that decimal, you'll see that it will in fact match our graph. Now the y-intercept, we're going to let our x value equal 0 this time. So we'll have our negative 16 times our negative 5. On the right-hand side, we're still going to have that y minus 3 quantity squared. So on that left-hand side, that's going to clean up to an 80. And what you'll notice is that this form sets us up to solve by square roots. So we can take the square root of each side. So we'll have our y equals 3 plus or minus, simplifying that square root of 80 is going to give me 4 radical 5. So then I could write that as an ordered pair. I'm going to slide this up for us. I can write that as an actual ordered pair, and we're going to write a lot of ordered pairs like this throughout this chapter. 0, and I can just write it together. 3 plus or minus 4 radical 5. Okay, now the last example that we're going to do on this page, we're just going to do 2 on this page. We're going to, instead of doing a full graph, we're just going to take our equation. This is going to let us practice writing this in standard form. So we're going to review what we did before in the previous video, looking at our equation here. So I'm going to have my x minus my 11. Remember, we like to insert that blank. We're going to factor out that coefficient, not the GCF. Y squared minus 6y plus a blank. Then I'm going to balance my equation. A 9 goes in the blank, has to balance, puts an 18 on the other side, gives me an x plus 7, 2, y minus 3, quantity squared. Don't forget, the coefficient and the exponent need to be on opposite sides, so that's going to become a 1/2 x plus 7, and then a y minus 3, quantity squared. So we're going to get that in the standard form, and then we can actually start using that equation to approximate some things. So from this, we can read our vertex, the xy, looking at the x and the y. So we have a negative 7, positive 3. Now, from this equation, we can see that it's the y term that's been squared, so that in our coefficient on the other side is positive. So we know that our equation, our graph in general, has to follow this form. So I like to go ahead and put that negative 7, 3 right there, and I don't even necessarily put it on a grid. My axis of symmetry, I can see, is going to be a y equals, and of course it would need to go through the y coordinate, so it's y equals 3. For my p-value, I'm going to remember 4p is going to be set equal to the 1/2, the coefficient. That means that I'm going to multiply both sides by, or I'm going to divide both sides by a 4, thinking what I'm really doing is multiplying both sides by a 1/4. So my p-value is 1/8. Okay. Now that means that what I'm going to do is I'm going to add and subtract that 1/8 from that x value. So I'm going to have a negative 7 plus or minus 1/8. I'm going to get my common denominators. So I'll have my 8 over my 8. So my new x coordinate for my focus will be a negative 56 plus 1, or a negative 55. 8, and then the y coordinate stays the same. Then I'm going to subtract that 1/8, so I'm going to have a negative 56 minus 1, so it's going to be an x equals a negative 57 over 8. And then the length of the lattice rectum, the LR, the length will be only a half. So if I was going to actually graph this, I would want to probably use my X and Y intercepts to get a few more points there. Okay, so that's a lot of stuff there. On the next page, we're going to do a compare and contrast of ellipses and hyperbolas.